Hi there, welcome back to our video on basic math or economics. We finished our unit so far in calculus, and now it's time to move back into things like algebra. So just like we did with the last set of videos, I actually want to start at the very beginning. Let's not assume that we've practiced this in a long time. So in this video, we're going to go back and we're going to talk about systems of equations. So anyways, just speaking generally, algebra is just one of those things that you're going to do a lot of, and you need to be comfortable with it, and you need to be efficient with it if you're going to be successful in your career in economics. So anyways, when we're doing algebra in economics, we're typically working with systems of several equations unknowns. So it's usually going to be more than one, and it can be many. I've done equations with n equations and n unknowns where I don't even know how many equations I have. And using these techniques, we can actually solve them out. So it's pretty neat because we have several different ways of organizing problems like this. And like all things with economics, the real trick is understanding when to choose each tool for each job. And that's one thing that will come with experience. So anyways, we're going to use standard algebra to solve simple situations like 2 equations and 2 unknowns, maybe 3 equations and 3 unknowns, but typically any situation where we're dealing with 3 or more equations and unknowns or less simple situations, we're going to rely on matrix techniques. When we get into non-linear ones, we're typically going to rely on simulations and computer techniques, but our focus right now is going to be on linear equations. So anyways, I want to examine a couple of these simple solutions in this lesson and the next couple lessons as well. But for now, let's just go completely basic. So let's start with a situation where you've calculated 2 best response functions for a Cournot duopoly of q1 equals 90 minus 1/2 q2 and q2 equals 90 minus 1/2 q1. Now these are best response functions that are actually representative of what you would see if you were working with a Cournot duopoly. I mean, I haven't just cherry-picked these at all. These are pretty standard best response functions. But as always in these problems, q1 and q2 are going to represent quantities for both firm 1 and firm 2 respectively. So in that first best response function I have, that's firm 1's quantity that they're going to produce is going to be 90 minus half of firm 2's quantity. And the same thing for firm 2, because it's identical to firm 1 in this case. They're going to produce 90 minus 1/2 of what firm 1 produces. So what we want to do is we want to solve this system equations for q1 and q2. So the first thing to know is there are 2 equations here and there are 2 unknowns, which should be everything we need to solve this out. So I'll start off by saying that there are many ways to do this. I'm going to show you one technique in this video, and then in another video I'm going to show you another technique. What I want to emphasize though is that there isn't just one way to do this, and the way you like doing this may not even be the way I like doing this, but if you're comfortable with solving these 2 equations and 2 unknowns, do whatever is most comfortable for you. I'm just going to look over a couple different techniques. The first technique, and probably the most commonly used technique, is what we call the substitution technique. And all you do for the substitution technique is you're going to plug one equation into the other. So these work out really nice for substitution because each equation is already solved for one variable. So all I'm going to do is I'm going to take the first equation and substitute it into the second equation for q1. So from the second equation I had 90 minus 1/2 q1. But now I've just replaced q1 with 90 minus 1/2 q2. I've just used its value. Well, anyways, from there it's just now one equation and one unknown. It's just a little bit of a complicated equation. So the first thing I want to do in this equation is get rid of those parentheses. So I want to distribute that 1/2 through. And so now my equation becomes q2 equals 90 minus 45 plus 1/4 q2. Don't forget that we're distributing negative 1/2 to those parentheses, so we have to carry the negative in there with us as well. So that negative times a negative equals a positive in this case. From there, the next step, I would just organize terms. So I want to combine everything with a q2 on one side of the equation and everything without a q2 on the other side. So in this sense, I'm going to subtract 1/4 q2 from both sides to get the 3/4 q2 on the left side, and then I'm going to combine 90 minus 45 to get 45. Well, it's starting to get much more manageable. All I need to do here is multiply both sides by 4 and divide both sides by 3. And from there, I get our solution, where q2 star, and I always use a star to denote an equilibrium, is going to be equal to 60 in this case. And that's my equilibrium quantity for firm 2 right there. That's all we need to do, just a little bit of algebra. And in fact, after using this, we can go back and we can get firm 1's quantity just by plugging in the value for firm 2's. So all I have to do is just plug in 60 for Q2 into firm 1's best response function, and I get 90 minus 1/2 times 60, which was firm 2's equilibrium value. So it's 90 minus 30, or just 60. And one important thing here is because the best response functions were identical or symmetric in this case, we should expect that both firm 1 and firm 2 would have the same answer. And that's actually a technique we're going to touch on later in this lesson, but be on the lookout for that because it can make your analysis much more straightforward. So what's neat about this is that we can extend this type of analysis to any number of equations and unknowns. As long as we have as many equations as we do unknowns, the same number, and also the equations are appropriately identified, which can be a problem in econometrics, we can solve any system of equations, which is fantastic. The problem, though, is that it may become cumbersome, and it may be easier to use matrices beyond 2 equations and 2 unknowns, and that's something we're going to look at going forward as well. So anyways, a couple other thoughts about this is if we're dealing with systems of equations and we don't have the same number of equations unknowns, problems can arise. They aren't guaranteed to arise, but they can exist. The first one is if we have more unknowns than equations, we have what we call an under-identification problem. Basically, we don't have enough information to solve the problem. So in those situations, we can have an infinite number of solutions. Basically, a whole spectrum of values that solve out these equations, just because we don't have enough information. So that's why we're under-identified. On the other hand, if we have more equations than unknowns, we have what we call an over-identification problem. Basically, there's too much information. And with too much information, that can lead to contradictions. And so in those situations, we could end up with no solution at all. Just nothing actually solves all of these equations for the unknowns we have. So when you're looking at these systems, it'll be rare, but you want to make sure you're looking to make sure you are properly identified. And again, that's going to be a bigger problem for econometrics than any other field in economics. So anyways, that's all for this video. In the next video, we're going to move into matrices because we're going to find that matrices are going to be very useful for solving a lot of these situations. Anyways, thanks for watching.